Why has nobody ever reached the bottom of every ocean trench? Imagine standing on the summit of Mount Everest. Now imagine turning the entire mountain upside down and lowering it into the Pacific Ocean. Even then, its peak would still not reach the deepest place on Earth. Hidden beneath the oceans are enormous cracks in our planet's crust. Some stretch for thousands of kilometers. Others plunge deeper than any mountain rises above sea level. These are ocean trenches, the deepest, darkest, and least explored places on our planet. For centuries, humanity has crossed oceans. We have mapped continents, climbed the highest mountains, walked on the moon, sent robotic explorers to Mars, even launched spacecraft beyond the edge of our solar system. Yet one astonishing fact remains. We still have not explored every ocean trench on Earth. Why? Why is it easier to send a spacecraft hundreds of millions of kilometers into space than to reach the bottom of our own oceans? The answer begins with an invisible force: pressure. At sea level, every person on Earth lives beneath the weight of Earth's atmosphere. Fortunately, our bodies are perfectly adapted to it. We never notice it. But beneath the ocean, everything changes. Every 10 meters you descend, the pressure increases. At 100 meters, the force pressing against your body is already about 11 times greater than at the surface. At 1,000 meters, sunlight has completely disappeared. The temperature hovers just above freezing. Darkness becomes absolute. Yet the pressure continues rising. 3,000 meters, 5,000, 8,000. Finally, at Challenger Deep inside the Mariana Trench, nearly 11 kilometers below the surface, the pressure exceeds 1,000 times the atmospheric pressure we experience every day. Imagine balancing 50 fully loaded jumbo jets on an area roughly the size of a dinner table. That is the crushing force surrounding every part of a deep-sea submersible. There is no room for error. A microscopic crack, a tiny manufacturing defect, a failed seal no wider than a human hair. Any one of them could cause catastrophic failure in an instant. Unlike outer space, where engineers fight against emptiness, the deep ocean is constantly trying to crush everything inward. It is one of the harshest environments known to humanity. The darkness is equally unforgiving. At around 200 meters below the surface, sunlight begins to disappear rapidly. By 1,000 meters, night has become permanent. No sunrise, no sunset, no moonlight, no stars, only endless blackness stretching in every direction. If you switched off your lights, you would see absolutely nothing. Not your hands, not the ocean floor, not even the submersible carrying you. Vision becomes almost useless. Scientists must rely on sonar, cameras, powerful lights, and sophisticated instruments just to understand where they are. Even communication becomes difficult. Radio waves, which allow us to communicate almost instantly through the air and across space, cannot travel effectively through seawater. Instead, deep-sea missions often depend on slow acoustic signals, messages that travel through water at the speed of sound. Simple instructions may take precious moments to arrive. Every operation becomes slower. Every decision becomes more complicated. And then there is the cold. Far below the surface, temperatures remain only a few degrees above freezing. Electronic systems must continue functioning. Batteries must keep supplying power. Hydraulic equipment must operate reliably despite the immense pressure. Every component inside the vehicle is pushed to its absolute limits. Building a machine capable of surviving these conditions is one of the greatest engineering challenges ever attempted. That challenge explains why so few people have ever reached the deepest parts of the ocean. In 1960, Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed inside a remarkable vessel called the Trieste. Their destination was Challenger Deep. No human had ever traveled so far beneath the sea. The descent lasted almost 5 hours. As they sank deeper into the darkness, strange cracking sounds echoed through the pressure hull. Every unexpected noise raised the same terrifying thought. Was the submersible beginning to fail? Neither man could know for certain. Turning back was no longer simple. The deeper they descended, the farther they were from rescue. Finally, after hours of careful descent, they reached the seabed. Outside the small viewing window lay one of the least explored places on Earth. A silent landscape unlike anything humans had ever witnessed. Fine sediment covered the bottom. The water was perfectly still. There were no colorful coral reefs. No forests of seaweed, only darkness, silence, and a world almost untouched by human eyes. Their visit lasted only a short time before they began the long ascent back toward daylight. It was one of the greatest exploration achievements in history, yet what happened afterward may be even more surprising. For decades, almost nobody returned. While humanity sent astronauts into orbit, landed on the moon, and explored distant planets, the deepest ocean remained largely untouched. Only in recent years have a handful of additional expeditions revisited Challenger Deep using modern submersibles. Even today, more people have stood on the surface of the moon than have personally visited the deepest parts of Earth's oceans. And Challenger Deep is only one location. Across the Pacific, Atlantic, Indian, Southern, and Arctic oceans lie dozens of major trenches. Some have been mapped only roughly. Others remain poorly understood. Many have never been visited by a crewed submersible. Scientists know these places exist. But knowing where something is very different from understanding what it contains. Every new expedition brings unexpected discoveries. Transparent creatures drifting through the darkness. Strange fish adapted to crushing pressure. Microorganisms surviving where life once seemed impossible. Each mission reveals another piece of a puzzle that is far from complete. Which leads to an even more extraordinary question. If every journey to the bottom reveals something humanity has never seen before, what might still be waiting inside the trenches we have never explored at all? Every great expedition begins with a question. And every expedition to the deepest ocean seems to end with even more. For decades, scientists believed the ocean trenches might be almost lifeless. The conditions seemed too extreme. Crushing pressure, near-freezing temperatures, permanent darkness. Almost no food. It appeared impossible for complex life to survive. Nature had other plans. As robotic explorers and deep-sea submersibles descended into the trenches, they found something extraordinary. Life was everywhere, not in the way we see it in coral reefs or shallow coastal waters, but in quieter, slower, and remarkably specialized forms. Transparent sea cucumbers slowly crawled across the soft sediment. Tiny crustaceans known as amphipods searched for organic material drifting down from the surface. Delicate worms burrowed beneath the seabed. Even fish were discovered swimming at depths once thought impossible. Every discovery challenged another scientific assumption. How could living cells continue functioning under such incredible pressure? At Challenger Deep, every square centimeter of an animal's body experiences a force greater than the weight of a small automobile. Yet these creatures move normally, feed normally, reproduce normally. Their bodies have evolved over millions of years to function where almost every other organism would be crushed. Their cells contain specialized molecules that protect proteins from collapsing under immense pressure. Their membranes remain flexible in freezing temperatures. Their biology follows rules that seem almost impossible to us. In many ways, they are as alien as anything we might hope to find on another planet. And perhaps that is exactly why scientists are so fascinated by them. If life can survive here, could it survive elsewhere? Far beyond Earth, several icy moons orbit the giant planets of our solar system. Europa, one of Jupiter's largest moons, hides a global ocean beneath kilometers of frozen ice. Enceladus, a moon of Saturn, sprays enormous plumes of water vapor into space from an ocean hidden beneath its icy crust. Neither world receives enough sunlight to support life as we know it. Yet the deepest parts of Earth's oceans have already shown that sunlight is not always necessary. Around hydrothermal vents, entire ecosystems survive using chemical energy released from Earth's interior. This process, known as chemosynthesis, transformed our understanding of biology. Life does not always require sunlight. It requires energy. That single discovery changed the search for extraterrestrial life forever. Instead of looking only for Earth-like planets with warm sunlight and blue skies, scientists now search for hidden oceans beneath ice. If life exists in the deepest trenches of our own planet, perhaps similar ecosystems could exist elsewhere in the solar system. The ocean floor has become a training ground for space exploration. Robots designed for deep-sea missions often inspire technologies later proposed for missions to distant moons. In a strange twist of history, understanding the deepest places on Earth may help humanity understand worlds millions of kilometers away. But the trenches have revealed something else, something far less encouraging. Humanity has already reached them, not only with submarines, but with pollution, plastic bags, fishing lines, metal cans. Even microscopic plastic particles have been discovered inside some of the deepest trenches ever explored. Scientists have found industrial chemicals inside organisms, living nearly 11 kilometers beneath the surface. Some deep-sea creatures contain pollutants that originated thousands of kilometers away. It is a sobering reminder that no place on Earth is truly isolated anymore. Even the deepest ocean cannot escape the influence of human activity. Perhaps that is one of the greatest paradoxes of modern exploration. We know more about the trenches today than ever before, yet we also realize how little we truly understand them. Scientists estimate that millions of marine species remain undiscovered. Many may live in deep environments that have never been sampled. Entire ecosystems may exist beyond the reach of current technology. Every expedition uncovers organisms completely new to science. Some produce unusual chemicals. Others display biological adaptations never seen before. Any one of them could transform medicine, biology, or our understanding of evolution. And still, most of the deep ocean remains unexplored. It is easy to assume that satellites have mapped everything, that modern technology has revealed every hidden corner of our planet. The reality is very different. We possess more detailed maps of the moon than of many parts of Earth's ocean floor. Large sections of the deep seabed have only been measured at relatively low resolution. Many trenches still await detailed exploration. Some may contain geological processes scientists have never witnessed. Others may hide species that have survived unchanged for millions of years. Perhaps future generations will look back at our time the way we look back at the age of sail, an era when vast regions of the world remained blank on the map, not because nobody cared, but because the technology simply had not caught up with human curiosity. The deepest ocean trenches remind us that exploration is far from over. The greatest discoveries are not always waiting among distant stars. Sometimes they lie beneath 11 kilometers of water, hidden by darkness, protected by pressure, waiting patiently for the next expedition. Perhaps the most remarkable fact is this: the ocean covers more than 70% of our planet, yet humanity has directly explored only a tiny fraction of it. Every descent into the abyss reveals another mystery, another species, another question, another reason to return. Maybe that is the true purpose of exploration. Not to reach the end of the unknown, but to discover that the unknown is always larger than we imagined. Because somewhere, in a trench no human has ever visited, the next great discovery may already be waiting. Silent, unseen, undisturbed. Until curiosity once again dares to descend into the darkness.